All right, you are welcome back to the second part of the linear programming we started. Again, we are into introductory mathematical analysis A. Introductory mathematical analysis A, and we are still in chapter 7. All right. Okay, previously we did a single inequality, and we drew the graph for a single inequality, and we were able to identify the region of solution. Now we are going into systems of inequality. That means when we have two or more inequalities. Okay, that is what we are going into now. So the solution of a system of inequalities consists of all points whose coordinates simultaneously satisfied all of the given inequalities. So just like we drew the graph for one inequality, we are going to be drawing for the two or more inequalities on the same graph and look for the region where all the inequalities are satisfied. Geometrically, it is the region that is common to all the regions determined by the given equalities. Okay, this region is called visible region. Okay, that is the region that is common to all of them. Okay, there are two ways to determine the visible region. Method A is that on the same set of axes, draw each inequalities and shade the region which is not a solution for that inequalities. So the first method is that you are shading region that is not the solution. Okay, for each of the inequality you are drawing. Now, after all the inequalities have been drawn, then the unshaded region is the visible region. So this first method, you are shading the side that is not the solution, and at the end you are going to have a region that is not shaded, and that region that is not shaded is the visible region. Of course, we must also comment on that and tell us that the unshaded region is the visible region. So you must comment on that. Don't forget, we mentioned that in the previous video. Okay, that is method A. Okay, the second method, as you will already assume, we are now shading the solution. We are shading the region that is the solution. Here we are shading the region that is the solution. So if you shade each of the inequalities with a different color, then the region that is the solution will now contain all the colors used. The one that contains all the colors used is the visible region. So here we are shading the visible region for each of the inequality. And then we are going to have at the end a region that contains all the colors, A region that contains all the colors. A region that contains all the colors, if you are using several colors, a region that contains all the colors, then that is now the visible region. Okay, so you can use any one of this method. Just make sure that you stick to it for each of the inequalities. Okay, all right, let's solve this example. All right, let's solve this example. All right, we want to draw this graph. We have number one, this inequality, and then number two, this inequality. So I call this one inequality 1, can call this one inequality 2. Okay, again, we use the same method as we know before. We find the equation of this. The equation for inequality 1. The equation for 1 is y equals to minus 2x plus 10. That is the equation for inequality 1. And from there, when x is 0, y is 10. When y is 0, then x is what now? X will be 5. Okay. Again, the equation for inequality 2, the equation for inequality 2 is y equals to x minus 2. Here, when x is 0, then our y will be minus 2. When y is 0, then our x will be 2. Our x will be 2. So we have that. Now we need to draw this. Take note of the highest value of y is 10 on the positive side, and the highest value of x is 5 on the positive side. Okay, let's draw our graph now. So we are more to this side and more to this side. Okay, this is x and this is y. Okay, I can decide to calibrate this 1, 2, 3, 4 up to 10, or I can use 2, I can use 4, I can use 6, I can use 8, I can use 10. So what I use here must be what I will use here. Minus 2, minus 4. Okay, here is just 5, so I can use 1, 2, 3, 4, 5. What I use here is what I use here. So it must be 1, 2, 3, like that, like that. Okay, you see I use 2 units here, I use 1 unit here. For both y, the positive y and the negative y, I use 2 units. It must be the same. You can't use 2 units on this side of y and use 1 unit on this side of y. No. All right. So let's draw the graph now. The first one, when x is 0, y is 10. And when y is 0, x is 5. Okay. So y is 10 and x is 5. Okay, I draw that one. Okay, let's determine, is it a solid line or a dotted line? It's a solid line. Because of this, is a solid. So both of them, they are solid line. We are drawing solid lines for both of them. Okay. So solid line for both of them. We have that here. Good. All right, so I need to determine which side am I shading. Again, I pick 0, 0. I pick my point 0, 0. And I try to test it in this inequality. I try to test it in this first inequality. So I will have 0 greater or equals to 0 plus 10. Okay, this will give me 0 greater or equals to 10. Is this true or false? Is this true or false? This is false. Okay, because that is false, it shows that the side I pick is not the solution. This side is the solution. So I need to decide, should I shade this side that is the solution or not? Okay, so you can decide. Okay, but let me shade the side of the solution. I'm shading the side of the solution for the first one. And whatever I do for the first one, I must also do for the second one. If I shade the side of the solution for the first one, I must also shade the side of the solution for the second one. You cannot shade the side of the solution for the first one and shade the side that is not the solution for the second one. No. So you must decide from the first line, from the first inequality, which side you must shade. So I'm shading the side of the solution. This is not the side of the solution. This is the side of the solution. That is for the first inequality, which is my y equals to minus 2x plus 10. That is this graph, that is this line. Okay, let's go for the second one. When x is 0, y is minus 2. And when y is 0, x is 2. Y minus 2, s2. Okay. Y minus 2, s2. You see? So again, I'm drawing a solid line. Y minus 2, s2. Okay, that's fine. So I'm drawing a solid line. I'm drawing a solid line. Okay. Now again, I determine which side to shade. I pick 0, 0. And I put it into this inequality, 0, 0 into this inequality. I'm going to have 0 greater or equals to 0 minus 2. 0 greater or equals to minus 2. Is this true or false? Is this true or false? 0 greater or equals to minus 2. Yeah, this is true. This is true. So that shows this side I pick is the solution. That side I pick is the solution. Okay, because that side is the true side, so I shade that side. You see? I shade the side that is the solution. 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 Okay, so you can now see now. So now let's determine our visible region. Our visible region is the region where we have both color. So you can now see that our visible region is this region. Our visible region is this region. This region is our visible region. This region is our visible region. So I'm now using yellow now again for that region. So that region is our visible region. You can call it our visible region. Our visible region. So this region is our visible region. All right, so you can now say the shaded region in yellow called FR is the visible region. Is the visible region. So you must always tell us which region is your visible region. So our visible region is the one shaded in yellow, more in yellow here, and also I call it FR. So that is my visible region. Okay, please take note of that. That is how to draw more than one linear inequality. So sometimes the inequality could be 2, could be 3, could be 4. You draw the same thing as we have drawn. Okay, please take note and make sure that you understand. All right. Now, just like equations and systems of equations, systems of inequalities also have, number one, no solution. So we can also have no solution for system of inequality. This is if we don't have a visible region. We don't have a region that is common to all of them. Okay, or our region is unbounded above, or when we need to find a maximum. So sometimes when we need to find a maximum and it's bounded above, then there's no visible answer for that. And if it is unbounded below, and we need to find a minimum, then there's no visible region for that. Okay, like the example we have done now. This one is unbounded above. So if I ask you to find the maximum now, you will understand that when we go into linear programming proper. If I ask to find the maximum or to maximize the objective function, you can't get the maximum here because it's unbounded above. Okay. Now we can also have number 2, unique solution. Unique solution, if we get an answer, that is a unique solution. And then number 3, system of inequalities, you can have infinitely many solutions. Infinitely many solutions. If 2 corner points are the maximum or minimum, if we have 2 corner points, we are going to understand this later when we go into linear programming proper, but let me show you this first. So this is a corner point. Anywhere we have 2 lines intersecting, that is a corner point. This is a corner point. This is also a corner point. This is a corner point. This is also a corner point. You will understand better when we go into linear programming. Okay, so we have infinitely many solutions if 2 corner points are the maximum or minimum. In this case, any point on the line between these 2 corner points is a solution. Any point between those 2 corner points that are maximum or minimum, then is a solution. That is what we call infinitely many solution. Infinitely many solution. Okay, I hope you understand that. Then we are going to go into linear programming proper, where we will make use of these things. Okay.